Hi, I'm Rahul Mushni, and this video log demonstrates the background and the working of the project, linearizing the response of the power amplifier with RF safety system. The main idea behind this project is to perform digital predistortion using genetic algorithm and getting linear response of the power amplifier. As we know, while performing digital predistortion on polynomial function with higher orders can be unstable. Hence, as a safety measure, RF safety system has been implemented in this work. This flowchart shows the working of genetic algorithm. Firstly, initial population are selected on random basis but in this work, initial population has been defined by the search space based on the gain. That is, the individual are selected where the gain is between the maximum and the minimum gain of the input and the output signal of the power amplifier. Based on this, the error tends to reduce a lot. Once the initial population has been selected, then it is evaluated based on the fitness function, and here the fitness function is mean square error. After this stage, best fit solution is taken and goes to the crossover section. Crossover is based on 1 point crossover, and again the best individual goes for mutation. In this stage, mutation is done by keeping the bond factor of 1. For instance, let us consider two variables a1 and a2 has the best fit solution after crossover, and this value is mutated for get a set of solution. Let us consider the two values a1 and a2. We can see that the first decimal place is increased and decreased by 1. Similarly, this is done for the remaining decimal places. After this, the combination of each solution for a1 and a2 are passed to the fitness function for getting the fittest solution. If the solution is acceptable, then the algorithm is terminated, else the process keeps repeating. This is the block diagram for digital predistortion, where the input is fed to the power amplifier, giving the nonlinear response. The output is again goes to the genetic algorithm block, where the coefficient gets trained, giving the inverse characteristics of the power amplifier, and again it's fed back to the power amplifier, giving the linear response. The below table shows the comparison of the results when the initial population is selected randomly against the population based on defined search space. By seeing the result, we can say that error has been reduced drastically, and this makes computation process fast. After implementing genetic algorithm on the measured signal having bandwidth of 5 MHz gives the inverted characteristics of the power amplifier, and this leads to the linear response. Coming to the safety system, the block diagram shows the proposed model for the safety system, and in the upcoming video will show the working of the safety system. Hi, this demonstration shows the working of genetic algorithm. First, we start with selecting the initial population. Here the population is selected based on the gain as mentioned earlier. The initial population is of size 25, hence each coefficient a1, a3 and a5 are of size 25. This solution are passed to the evaluation stage, getting the fitness value, and the top error over here is 2.8218. And as you can see, after each generation, the error tends to reduce. Now, in the second generation, the error goes from 2.8218 to 0.1124, and in the next successive generation we can see the error reached to 0.0018. The graph shows the three signal. One with the blue line shows the original signal, whereas the red one represent the inverse characteristics, and the yellow one shows the linear response after DPD. This video demonstrates the RF safety system implemented in this work. First, we'll be connecting Arduino and vector signal generator SMU200A by Roden and Schwartz with MATLAB. Now, we'll be setting up the frequency and the power level using the Visa instruction. So the current frequency is 1 gigahertz. Here we'll be turning on the power supply for the power meter. The power meter here used is ADL5519. Now we have initialized the power sweep settings. The range has been given for -10 dBm to -40 dBm and the frequency is for 1 gigahertz. As you can see, the LED is being glowed. That means the voltage is supplied to the power amplifier. Since at -11 dBm the power supply is high, the DC supply turns off. As you can see, the sweep increases by -1 dBm. Once the signal reaches the power that is within the set point value, then the DC supply will be turned on again. Since the range for the power sweep was -40 dBm, once the signal generator reaches the -40 dBm value, the RF supply will be turned off automatically. Thank you for watching this video.